we have amount equals percent times base, which we abbreviate as A equals P times B. And as far as what each of those components means, amount and percent are just two different ways of representing the same quantity. So on pizza night at my house, let's say we cut our pizza into 4 slices just to keep things simple. We have sort of a 75-25 policy at my house. So this is my son's portion of the pizza. So Riley's pizza. He gets 75% of the pizza. How many slices of pizza does he get? 3, right? So 3 slices is the amount that is represented by this percent. So saying Riley eats 75% of the pizza is the same as saying Riley eats 3 slices. So the amount is actually counting like physical objects, right? So they represent the same quantity. One represents it as a portion, that's the percentage, and one represents it as a number of slices or number of dollars or number of people. That's the amount. But they always represent that same quantity. So in this case, both of them represent how much pizza Riley is eating. They just represent them in a different way. And those have to match up because that's built into the equation. If we had the percent represent the yellow portion and the amount represent like the amount I eat, so like 1 piece, if we plug those in as the percent and the amount, the equation wouldn't work out. If we solve for the total number of pieces, we wouldn't get 4 because 71 piece is not 75% of the pizza. So that percent and amount have to represent the same quantity in order for your equation to work out numerically because it's built into the equation that they represent the same thing. And so we're going to set up a couple of these just with numbers, and then we'll throw some variables in there here in a sec. So the general setup for all of these problems, and this is the only place where it kind of differs from what we did yesterday, is there's sort of a general setup for percent problems. It's always the same, and that's going to be like your first step where you list the unknowns. So our components are always amount, percent, and base. You can write the words amount, percent, and base, but you'll do this so much you might want to abbreviate. Those aren't necessarily variables. I'm just abbreviating. And then the really important part is to state what each of them represents. So saying that I have an amount, I have a percent, and I have a base, it's true, but it's not specific to the problem that we're talking about, right? It has nothing to do with, in this case, students or how many of them pass the class. And so in this first step, you always want to make sure that in words you're relating the amount, percent, and base to the actual problem, so what's actually going on. So in this case, what does the percent represent? What's special about that 80%?
Percent pass.
Yeah, they pass. So this is the percent that passed. And if the percent represents the portion that passed, then the amount also has to represent the portion that passed. So remembering that the amount and percent represent the same thing can help you figure out which numbers go where, because the percent's fairly easy to find. It's the only thing that has a percent sign on it, right? So if you can figure out what that represents, then you can say, okay, do I know how many people passed? 20 people passed, and so that has to go here. And then that corresponds to 80% of the class. And then our base is going to be the total number of students. And that, in this case, is 25. And amount equals percent times base. And you always want to write your percent as a decimal in order to do calculations with it. Depending on your calculator, if you have a scientific calculator, most of them, like graphing calculators, don't have percent buttons, but you won't use those on the test anyway. You're on this calculator, the left parenthesis is a percent button. So if you type in 80 and then hit the percent button, it'll change it to 0.8 for you. That one's fairly simple, but it's the kind of thing that you can do a million times perfectly outside of a test. And then when you're taking a test and you're already stressed out, all of a sudden you convert incorrectly just because of the stress of taking a test. So use your calculator to help you avoid little things like that on a test. So now we're going to deal with the tip. We have two basic types of percent problems. One of them is like our first one, where the base represents a total, like a whole, and the amount represents some portion of that. The other type is when you're starting with some value, some base value, and it's actually going to change. So like when we leave a tip, the amount that we're paying for dinner changes, right? When we add the tip on. And so the amount is, or the base price of the meal is actually changing because of the tip, as opposed to up here, like the total number of students in the class doesn't change when we find out how many pass, right? We're not adding more students to the class, as opposed to down here, when we pay a tip, we're adding more money to the bill. So those are sort of the two different types of equations or situations. And where that comes up is that if it is a problem involving change, your base is always going to be, I should call it price, the before value. So before the tip, before the discount, before the increase, before the decrease. And this is easy to remember because before starts with B. And then A is going to represent the, in this case, cost after the change. And again, A starts, or after starts with A, so it's kind of nice that these correspond like that. Amount is after, base is before. And then our percent has to represent the same quantity as our amount, which means this has to be the percent paid after the tip. So it's not the percentage of the tip itself, it's the percentage, the total percentage of the original amount that you're paying. So what is the cost after the tip? $54. Oops, not percent, dollars. And the price before the tip was $45. What percent of the price before the tip am I paying in total? Do I pay 4% or 20%? So if you go out to eat and your dinner bill is $100, do you pay $20? How much do you pay? $120, right? You have to pay for the meal, and then on top of that, you're paying the tip. And so we have to pay for 100. I'm not being consistent. Sorry. It doesn't really matter, but we have to pay 100% of the price of our meal. And then in addition to that, we have to pay 20% for the tip. So this is my meal, and this is my tip. And so the percent, the total percent paid is going to be 120%, which is 1.2. So that's the main difference between these problems that involve change as opposed to problems where we're just taking a portion of the whole. is that the percentage after the change is always going to be the 100% you started with, and then either plus the percentage you're changing it by or minus the percentage you're changing by, depending on if you're going up or down. This setup isn't the only way you can approach some of these problems. We could have said that the amount is the amount of the tip and that the percent is the percent of the tip, and then that would be 9 and 20%. However, when we get to problems where we don't know the cost before, so we don't know the base, we have to set it up this way, as opposed to having the amount in percent just represent the tip itself. And so I think it's easier to learn one way of setting this type of problem up and use it for all the problems instead of doing it one way sometimes and doing it the other way sometimes and having to remember both. So I always include in my percent that 100% that I started with and then go up or down from there, as opposed to making the percentage just the tip and then trying to add it on later on. So let's do a few problems now where we'll solve for some unknowns. Oh, I didn't write this down. The equation is 54 equals 1.2 times 45. And that should be true, I hope. Okay, so when an unknown is involved, we're going to set the problem up exactly the same way. I want to give you fair warning. If you, on your homework, don't write these things, I'm just going to give it back to you, and you're going to have to do it again. So you might as well just do it the first time. It's tempting to like skip that part and try to jump right to the equation. But like I said, as we keep going, these are going to get more complicated. And setting it up so that you know what everything represents is how you make sure that all the numbers in your equation actually correspond to each other in the way that you meant for them to. So you end up doing it accurately. So we're going to set it up the same way here. We have a solution containing 30% acid, and we want to know how much acid 90 milliliters of the solution contains. This is actually the main reason that we teach percents in this class, is for chemistry. So it's one of the only places, if you're like a math major, you'll probably never use percents in your life. But if you're a chemistry major or a nursing major and you have to take chemistry, then you get to do these solution problems. So you'll see lots of these like 30%, 40% acid things. So what does that 30% represent in this solution?
How much acid?
Yeah, how much acid it is, right? This is saying if you could somehow separate the pure acid from the water, that 30% of your solution would be pure acid, and then the other 70% would be pure water. And so our percent is how much acid is in the solution. And that means our amount has to also be how much acid is in the solution. And then our base, in this case, the total amount of solution isn't changing. So it's not a before and after situation. Our base is just the total amount of solution that we have. So we know that we have a 30% acid solution, and that 90 milliliters is the total amount of solution that we have.
So is A just X?
Yes, and so we don't know how many milliliters of acid we have, and so that's our unknown. And then our equation is A, which is X, equals our percent times our base. On your homework tonight, you're asked to do only the first two steps, which is the setup, so identifying what your variables represent, and then writing the equation. So I don't want you to solve the equation. I don't care what the answer is. I'm not going to mark you down for like solving the equation if you do solve the equation, but the only part that contributes to your grade are these first two. So if you write an answer you didn't do these first two steps, even if your answer is right? Because the answer to the questions is the first two steps. So be sure you're doing your setup completely. I'm pretty sure you can plug that into your calculator once you get it set up, so I'm not too concerned with seeing that. I just really want to see the setup. We'll solve it just for the heck of it. It's like 27 equals 27. So 90 milliliters of solution contains 27 milliliters of acid. Which is a little hard to think of because like you can't like measure the acid separately, but if you could separate the water from the acid, this is just saying that the acid itself would take up 27 milliliters of volume. So the next one is the same exact idea, same setup. So go ahead and try that one and solve for the concentration of acid. So concentration just means the percent that is acid. You could just repeat the labeling that we did in the previous problem. It's the same situation. I'm not like super picky about like how you write the words, as long as your amount and your percent match and it makes sense in terms of distinguishing that from like the total. You just want, like, your labels should describe like how the amount is different from the base, right? So like, did we do the student one yet? I guess like in example 1, both the amount and the base are students, but if you write students and students, then it doesn't really tell you how the amount is, the value that the amount represents is different than the value that the base represents. So you want some sort of distinguishing feature in there. So we have the amount, which represents how much acid is in there, the percent, which also represents how much acid there is, and then the base is our total milliliters of solution. We know that there are 16 milliliters of acid in 80 milliliters of solution, and we don't know what percent that represents. So we have 16 equals x times 80, which gives us x equals 0.2, so it's a 20% acid solution. As I was walking around, it looked like everybody had basically exactly that. So, oh, I didn't close my parentheses. Oh, there we go. So far, so good? Any questions? Okay, so I'm going to have you guys do number 5. And then we'll start talking about these ones that represent change. So go ahead and try number 5. So now let's talk. So everything we've done so far as the ones we've solved, have dealt with the whole as a total amount and the amount as like a portion of that. So the number of students wasn't changing, the amount of solution that we had wasn't changing, etc. Now we're going to start talking about problems where we're actually changing. So when we pay sales tax, that changes the price that we have to pay, right? So that is my indicator that I need to switch gears a little bit, and now my base needs to represent before the change, my amount needs to represent after the change. So we're going to start with our basic list. And my amount is going to be the price after, I should say paid after, and this is the percent that's paid after. And this is the cost or the price before. a discount. So I threw that word paid in there because another way you can think about this to kind of help yourself, it's not a discount. Sorry. I'm jumping ahead. Tax. Is if you think about what you're actually paying for, right? So we're paying for both the coat and the tax. And so what we're actually paying includes both my base amount and also the tax, not just the 4%, right? So what percentage am I actually paying after tax?
100.
Right, so it's the price of the coat, which is 100% of the price of the coat, plus the tax, which is another 4%. So you want to ask yourself, I guess I'll do that in 2 steps. 4%. When you write that, you want to ask yourself, like if you write 4% there, ask yourself, like, am I actually paying 4% for this coat? I mean, that'd be sweet, but it's not the case, right? We have to pay 100% of the price, and we have to pay the 4% on top of it. And then the price after, we don't know the total cost. And then the price before is $75. So we have X equals 1.04 times 75. And that is 7.1. 378. At least somebody's checking. I feel like you guys might take my word for it if I just throw it out there. So what that tells us is the total price that I have to pay for this coat is $78.
So do you have to do it where you add the 100%?
In this problem, you don't have to. What we will find in the next couple problems is that there are problems where you have to. And so I find it easier to do it all the time so I don't have to decide if it's a problem, one of the problems where it's necessary as opposed to the problems it's not. So the reason that some problems it's necessary is that if we don't know the price before, we can't just, like if in this case, if we knew the price paid after, and we said that our percent was just 4%, you can't take the price that's paid after and subtract it to get the price that's paid before, because you're taking a percentage of a different number than, right? When you take when you calculate tax, you take the price, you calculate 4% of the price before. If you don't know that price, then we don't know the value of 4% of that, so we can't represent the amount of the tax alone. We can only say the amount with the tax is whatever the number they gave us. So we have no way of separating the 100% from the 4% if we don't know the base amount. And so that's why I include it is so that as the variable, where the variable is changes, we can still solve the problem. So it's like if you said that the amount is the tax and the percent is the tax, on this problem it would work fine. I just kind of like to streamline it and always do the same thing as opposed to like trying to decide which I should use. Any other questions? Good? You good, Nick? Okay, so we're purchasing another coat. Maybe I was cold when I wrote this. It's really into coats. For $123 during a 25% off sale. So the amount I actually paid was $123. So that included the discount. So that's the price of the coat after the sale. So I'm going to say my amount is the price paid after the discount, and the percent is the percent paid after the discount. And my base, B is for before, so this is the price paid before the discount. And so we don't know the price before the sale. And I guess you could, if you wrote, instead of discount, if you wrote sale, that would mean the same thing. I guess we use sale in this question. So if we think of, again, that percent is what I actually paid. What percent do I pay for the coat?
25.
Yeah, right? If there's a 25% discount, that means that that's what we're not paying. What we are paying is 75%. So we can do it the same way we did the other one, or you can just figure it out. But we start with 100% of the price. That's the price of the coat. And then we don't have to pay for 25% of it. And so we do have to pay for 75% of it. And then the price paid after the discount is 123. So this kind of comes back to that whole making sure that the amount and the percent represent the same thing. It's easy to just see like a percentage there and be like, oh, the percent is 25, right? Because that's the percent you see. But if you put 123 in for your amount, that would be saying that 123 is 25% of the cost, which isn't the case, right? Because you pay the 123, you don't pay that 25%, you pay 75. So we are going to write 123 equals 0.75x, and x equals 41 times 4, 82, 164. And that's the price before the sale or the discount. So the original price was $164. So one sort of common question is like, why can't we just take 25% of 123 and just add it back on to get, would we get the same thing? So we're saying that if I take the base price and I go down 25%, that we get the sale price. So if you took the sale price and you went up 25%, would you get the base price? So the answer is no, and the reason for that is that a percentage is a portion, right? So 25% of one price is not the same quantity as 25% of another price. So for instance, if I went out to dinner and it cost $100 and I had like a 25% off coupon, if I take 25% off, I'm taking 25% of 100, which gives me a $75 bill after the sale. If I try to go the other direction, what do I get if I add 25% of 75?
Less than 25.
It's like $94, I think. $93.75. Shouldn't have this arrow pointing to this. You get $93.75. And the reason for that is that 25% of 75 is not the same as 25% of 100, right? So if we don't know what this value is, there is no way for us to figure out what we have to add back on to the 75 to get that original price, right? Because that discount has to be 25% of the original price, not 25% of the final price. So sort of the first thought is always like, oh, why not just do it backwards, right? Like if I know what I end up with, why not just add that discount back on and I get the original price, which theoretically would be true, except that we can't figure out the amount of the discount, the dollar amount of it, unless we know the original price by taking a percentage of that. And so that's why on these ones, you have to incorporate that 100% into the setup and have the amount in the percent represent the total value, because there's no way to separate that discount out from the total price that you pay afterwards. So like I said earlier, the first problem we did, this one, we could set up differently, but then number 7, that's really the only way to set it up for it to work. So do with that what you will. If you want to set some of them up one way and some of them up another way, that's fine, as long as you're using something that works. So I'm going to have you guys do number 8. This, again, is a change situation, right? Our population is changing. And so we want to think, again, about the after, the before, and the percent. Amount of people is how much my population changed by. Then when I solve, this percentage is going to be the percent that it changed by. Whereas the problem on the top, sorry, the last thing I did in my last class was show them what not to do. If you said, okay, my amount's going to be the population after the increase, and the percent is going to be the population, or the percent after the increase, then when you solve for x and you get 1.07, does that mean that the increase was 107%?
In that case, yes, but not in the actual increase.
Right, so the percent after the change was 107%. The increase itself was only 7%, right? So this is where it's important to be consistent, is you have to know what it is you found. Like, it's easy to be like, oh, that's X, so that's my answer, right? So sometimes you have to do a little bit with it to get your final answer. The most common error on these is to do something like this. So you're saying that the amount includes the original plus the increase, but then you're saying your percent is just the increase. And that's where you'll run into trouble, is if they represent two different things. So if your amount represents after, but your percent only represents the change. So like if on this, the number, where am I? Number 6, if you said 4% for your percent, then that would represent just the tax, whereas the $78 represents the tax and the cost of the coat. So you just have to be careful that you're consistent in having your percent and your amount represent exactly the same quantity, and then refer back to what they represent when you're actually answering the question, and you should be fine. Really, the main problems that occur with these are just due to inconsistencies. So that's why we write everything down so we know exactly what we mean when we find an answer. So your homework